Hi everyone, in this video we will be going over ratios and proportions. Our essential question for today is, how are ratios and proportions used to compare and solve real-world problems using and involving two quantities? So once again, how are ratios and proportions used to compare and solve real-world problems involving two quantities? So first let's talk about ratios. A ratio is a comparison of two numbers by a division. And we've talked about this a little bit during this year, and basically a ratio, it's going to look like a fraction to you. You're comparing one thing to another, such as something that's in the numerator by something that's in the denominator. But they can be shown in several ways. You might see it as 1 to 4, where it's being separated by a colon. You could see it as 1 over 4, which is a fraction. Or you might even see it written with words, such as 1 to 4. And all of these are comparing one value to another. So maybe in the 1 to 4 ratio that we're talking about, let's say 1 orange per 4 fruit in a basket. So there's 1 orange out of the 4 fruit that are in the basket, and you're comparing that. And by comparing that, you're dividing, and you're saying that 1 out of 4 of those are oranges. Or if you were to divide, you would also be saying that that is 0.25, or 25% of those fruit are oranges. So again, it's all about comparing one quantity to another. Now, let's look at an example. The Kelly family has 8 pets. 3 of them are dogs, 2 are cats, 2 are chickens, and 1 is a turtle. So find the ratio of dogs to pets, cats to pets, cats to dogs, and then turtles to chickens. And we're just going to write it in the form such as this with our colon. So in the first case, we look at dogs, and there are 3 dogs and the number of pets. So we've got 3 dogs and we've got 8 pets. So then when we write that, that just simply becomes 3 to 8. Now for cats to pets, we've got 2 cats and 8 pets, which is 2 to 8, but then that reduces to 1 to 4. All right, again we have 2 cats, but this time we're comparing it to dogs, and there are 3 dogs. So that would be 2 to 3. And then we also have turtles to chickens, and there's 1 turtle and 2 chickens. And so then our ratio would be 1 to 2. Now, one thing that's important to note, in all these we ended up with like proper fractions, but you could have improper fractions, such as if I said dogs to cats, instead of cats to dogs, that would be 3 to 2. So your ratios could be improper as well. So you have a couple problems to try. Put these on your foldable and then input them into Edpuzzle. So now let's talk a little bit about proportions. A proportion is a set of 2 ratios that are equal. So before we were creating one ratio, now we're looking at 2 ratios, and they are equivalent, they are equal. So that is a proportion. If it is not a proportion, then the 2 ratios would not be equal. So if we look at this problem, we have 2 over 5 equals 4 over 10. And then the question is, are these proportional? Are they equivalent to one another? And in this case, they are going to be proportional because when they are reduced, they're equal to one each other. So 2 over 5 cannot be reduced, but 4 over 10, that can be reduced to be 2 over 5. And since this fraction is the same as our other one, then that means these 2 are proportional. Another way you might hear it sometimes are equivalent. So these 2 are proportional. Now, there is a really great rule that you can use that helps you to find out if something is proportional, and this is called the cross product rule. It's really helpful in those where maybe you have large numbers that you're trying to reduce, or you're working with decimals. This makes it a lot easier. But it's a great way to check if 2 ratios are proportional. And the cross product rule states that if 2 ratios are proportional, then their cross products will be equal. Now let's think about that problem again. Cross product means you are looking at the 2 numbers across from each other, and product means that you're multiplying them. So you're multiplying those 2 numbers that are across from each other. And if those 2 numbers are equal to each other, then it's a proportional relationship. So 2 over 2 times 10 would be 20, and 4 times 5 would also be 20. So to check if a relationship between two ratios is proportional, you can just use the cross product rule. So once you multiply those two numbers that are across from each other, if you find out that they are the same, then they're proportional. But if they were different, then that would mean that they are not proportional. Now let's look at proportional tables and graphs to determine, is this a proportional table and is it a proportional graph? Now, a proportional relationship is one where the ratio between the two variables, such as x and y, is a number k. So it kind of resembles what we used to do with slope. It's kind of similar to that. And all we're doing is we're looking at, if I take my y value and I put it over my x value, what is that? What is that number? And then if they're all the same, then it tells us it's proportional. And you can see it written in either way. Right now, we're working with it as y over x because we're comparing the y to the x. Remember, we've got two quantities and we're comparing them. We're creating ratios. And another way you'll see it sometimes written is y equals kx. And this should look very similar because it's very similar to our slope and our slope-intercept form that we're talking about earlier in this year. So let's look at the ratio of y over x and then compare and see if they are proportional. But first I'm going to just plot these. So if I take these points and I plot them, I do end up with a straight line. So that is helpful to know, and it will kind of help us to determine as well when we're looking at the graph if it is going to be a proportional relationship or not. So right now let's just go over here and let's create our fractions. So the first one is going to be 1 over 0, which is undefined. So that is, again, the y over the x. Then I've got, this is a little bit backwards. It doesn't really matter what direction you put it in, if it's x over y or y over x, but then this would be 2 over 1, which is just 2. And then we end up with, 3 over 2 and 4 over 3. Now, as you can see, these are not all the same numbers. And since these numbers from here to here to here are not the same, that does tell us that it's going to be not proportional, because that value, that k value that we're finding, is not the same for each set of points. Now, on your graphs, if you were to look at it over here, you could even look at it visually and go, okay, so this would be 2 over 1, which is 2. Okay, this would be 3 over 2, which is 3 over 2. It's not 2. They're different numbers. And the big hint on this is, if it is a proportional graph, it starts at the origin. So it starts right here at 0. If it does not start at 0, then it cannot be a proportional relationship. Okay? And it has to be a straight line. So it has to start at the origin, and it has to be a straight line on the graph for it to be a proportional relationship. So for it to be proportional, one more time, these numbers should all be the same. And then your graph should start at the origin and create a straight line. So let's look at another one of these. So in this case, let's just go through and let's graph our points. And we can see this time that it does start at the origin and it does make a straight line. Now when I go over here and I create my values, y over x is going to be 0, 0 on the first one. And then I end up with 2 over 1 as my next set of values. I've got 4 over 2, and then 6 over 3. And as you can see, these are all reducing to be the same number, which is 2. And that's really important because that's telling us that the k for all of these, and you really don't take into account the first one when it's at the origin, but for all of these, they are the same. So those would all be your k values. And since your k values are the same, then that means that this is going to be a proportional graph. Another hint is that our graph started at the origin, and then it created a straight line going through here. And so since it started at the origin and created a straight line, we know that this graph is going to be proportional. All right, so you have two practice problems, and you're just going to determine which ones are proportional relationships. Now let's talk about solving proportions. The cross product rule, which we talked about earlier, can be used to solve proportions when there is an unknown value. So you might have an equation or a set of proportions or ratios that looks like this. And you want to use your cross product rule to help you solve this proportion. So we look at our cross products and then we multiply them. Well, 2 times n is just going to be 2n, but 10 times 5 is going to be 50. So now we know that 2n equals 50. Now to solve this equation, we divide by 2 on both sides, and then we get our answer as n equals 25. And think about that. If I put this over here and I said 10 over 25 equals 2 over 5, if I reduce that, it should equal 2 over 5. And it does, because 10 divided by 5 is 2, and 25 divided by 5 is 5. And those two are the same. So this means that n, it being 25, is our best solution. That is correct, because our goal is to make a proportional relationship. And by using 25, that does create a proportional relationship. All right, let's look at a word problem. The word problems can be the tricky ones, and they're not too difficult, but you have to make sure that you're setting it up correctly. Now, when we set this up, we need to basically just start with creating our fraction bars, okay? And it says a package for 4 home games costs $180. So I've got 4 home games that cost $180. Now on here, we just say, okay, well, I'm comparing, that is my ratio. I'm comparing 2 different quantities. I've got 4 games over $180. Now the next thing that we have to do is we have to make sure that we also set up the other ratio in the same way. And so if I have 4 games, if I'm talking about games in the numerator, then I also have to talk about games, the other side. Games need to also be in the numerator. Now on the bottom, I've got money, so I also need to have money that is in the denominator of our other ratio as well. So the next thing that we know, and this is where you guys have to really take your time and make sure you're reading, is so that you get all your information, is what number do we know next? Do we know it's in the numerator, or do we know it's in the denominator? And remember, this is going to have to be games over here, and this is going to have to be talking about money. But when we look at our problem, we know that we've got 12 game package costs. So we know that 12 games is going to go in the numerator. But we do not know the denominator, so that becomes x. And now we just have a proportion where we do our cross multiplication and our cross product rule, and then we solve. So when I do that, I get 4x, and then you can use a calculator for this. And 180 times 12 is 2,160. And when I divide that by both sides, I get x is $540. So if we were to reduce these, then this would reduce down to the same as our ratio over here. Now you've got a couple of practice problems, so take a minute and solve those. All right, the last thing we're going to talk about today is percent equations. Now, percent equations are proportions, and they help us to solve problems that are involving percents. Now, these are a set of 2 equivalent proportions that can be used to find the part, whole, or percent of an unknown quantity. And when we talk about this, we're talking about some sort of part over a whole that's being compared to some sort of percent over 100. Because think about that. This is the part, the numerator is always the part of the problem, and the denominator is always the whole. Whereas over here, let's say I've got 2%, that's part of it, right? That's part of 100%, but it's just part of it. So that is very important to write down. And another way that you might see it written as, and this really helps with when you're doing word problems, you might see it written as is over of equals percent over 100. So that gives you a big hint, and we'll go over that in a second, of what numbers go where. And your goal in these problems is to find which numbers do you place in here, and then what number are you trying to find. So what percent is 208 of 320? Now what I like to do is I go, okay, so I don't know what the percent is. That's the question. So that's going to be my variable. So what percent? And then I try to just box up the things that go together. So it says something is 208, and then of 320. That means those go together. So my is going to be 208, and my of is going to be 320. If you remember, we've got our formula as is over of equals percent over 100, and our is 208, our of is 320, but we do not know our percent, so that's going to be a variable, and 100 always goes in the denominator of that second ratio. Now we simply use the cross product rule, and again use calculator. In this case it's really easy, right? Because 208 times 100, you just add 2 zeros at the end. And then we divide by 320 on both sides, and we find out that x equals 65%. It's very important that you put down that percent on your homework as well, because when you put it into the Google form, it will mark it wrong if it does not have that percent. All right, so let's try one last problem. So this says 35% of the total length of the screen at an IMAX is 51.8 feet. What is the total length of the screen? So right here I see I've automatically got my fraction. Okay, so let's look at our problem. So I know, not our fraction, our percent. So I know I have this one right here. That's going to be our 35. And that says 35% of the total length of the screen is 51.8. And then what is the total length of the entire screen? So remember, this is part and this is whole. So which one is talking about a part and which one is talking about the whole thing? Now in this one, 35% of the total length of the screen is 51.8. So that's telling you that part of it is 51.8, but we're trying to find out the total length of the screen. So this time we don't know the of, but we did know these ones over here. So when we plug that in, we've got 51.8 over some unknown number. We don't know the whole length of the screen yet. We know that it's 35% over that whole then. So you simply use your cross product rule. So x times 35, and then 51.8 times 100. And we get 35x equals 5180. Divide by 35 on both sides, and we get x equals 148. All right, you have 2 more problems to try, and if you have any questions, please feel free to reach out to me and I can help you with those.